Under the vast expanse of the celestial sphere, a massive scarlet star, among the most luminous and easily distinguishable stellar bodies, asserts its dominance along the horizon. Situated far beyond our full understanding, this immense cosmic entity possesses the capability of releasing an energy magnitude that could rival the combined radiance of an innumerable array of stars. This astronomical giant, possibly on the verge of an apocalyptic event, may soon unleash an energy burst of such magnitude that it could outshine a billion suns. The real question is, are we prepared for the aftermath such an event could bring? This colossal red star, often referred to as Goliath, resides relatively close to Earth and has emerged as a subject of significant fascination and debate within both the scientific community and the broader public. Recently, this star underwent a considerable transformation, prompting growing concerns among researchers and fueling intense discussions regarding its future trajectory. The most alarming possibility is that this alteration might signal the early stages of a supernova, an explosive stellar phenomenon marking the final phase in a star's life cycle. If Alpha Orionis, the scientific name for the star, were to exhaust its nuclear fuel, it might collapse under its own gravitational pull, triggering a catastrophic explosion. The very thought of such an event sparks anxiety, not just among scientists but also for those of us inhabiting Earth, as the potential consequences could be extraordinary. The supernova threat. Alpha Orionis, easily recognized by its deep crimson hue, holds the title of being the largest and most radiant star in the Orion constellation. With the aid of advanced tools such as NASA's Hubble Space Telescope, astronomers have closely observed its behavior, particularly in 2019 when it experienced a dramatic loss of mass, a phenomenon considered rare for stars of this type. This event raised alarms across the scientific community. While our Sun frequently undergoes coronal mass ejections, the unusual event witnessed in Alpha Orionis has sparked a re-evaluation of what occurs during the final stages of a massive star's life. Scientists are currently divided over the precise distance of Alpha Orionis from Earth. Estimates vary, with some placing it as far as 1,200 light-years away, while others suggest it might be as close as 724 light-years. The difficulty in accurately determining the position of stars like Alpha Orionis lies in the immense distances involved and the peculiar nature of red giants. Despite uncertainties regarding its precise location, Alpha Orionis continues to captivate observers as one of the most awe-inspiring objects in the night sky, shining several times brighter than our Sun. However, this radiant glow comes at a significant cost. Alpha Orionis is consuming its nuclear fuel at a rapid pace, accelerating its journey toward the inevitable end of its life cycle. Once it exhausts its fuel supply, the star will likely collapse, possibly forming either a neutron star or, in a more catastrophic scenario, a black hole. Depending on how the explosion unfolds, could Alpha Orionis pose a threat to Earth? Should a supernova occur within a few light-years of our planet, the ramifications would be devastating. A supernova can release an unimaginable amount of energy, potentially outshining entire galaxies, which presents the possibility of far-reaching consequences, even if Alpha Orionis lies at a considerable distance from Earth. Historically, the last supernova event recorded within our galaxy took place in the year 1604, and since then, humanity has not witnessed a similar occurrence on a local scale. However, a significant supernova erupted in 1987 in the Large Magellanic Cloud, located a staggering 169,000 light-years away. Although this explosion had notable consequences for its immediate environment, it posed no direct threat to Earth. Nonetheless, these rare events serve as potent reminders of the immense scale of supernova explosions and the dangers they may present. The greater cosmic threat, gamma-ray bursts. While supernovae are infrequent occurrences, gamma-ray bursts, GRBs, represent an even more potent threat. These bursts are capable of annihilating entire planetary biospheres by flooding them with deadly radiation. For instance, GRBs have the potential to destroy a planet's ozone layer, leaving it exposed to harmful ultraviolet radiation from its sun, effects that could persist long after the burst itself has subsided. This looming threat has become a focus of recent research, shedding new light on the potential hazards associated with stellar explosions that culminate in such dramatic and destructive events. When massive stars explode as supernovae, their brightness can surpass that of entire galaxies. This intensity raises an important question. What would happen if Alpha Orionis were to undergo a similar transformation? The visible and invisible dangers of a supernova. Should it explode as a supernova, Alpha Orionis could become the second brightest object in the sky, second only to the Sun in terms of visibility. Even at a considerable distance, The energy released in such an explosion might be so intense that it could be visible even during daylight hours. This blinding spectacle would cast shadows in the middle of the day, offering a striking yet unnerving experience for those witnessing it. However, while the visible light emitted by a supernova would be a breathtaking sight, the real threat lies in the high-energy radiation accompanying such an explosion. One of the most pressing concerns is its potential to deplete Earth's protective ozone layer. Without the ozone layer, life on Earth would be exposed to harmful levels of ultraviolet radiation, potentially leading to mass extinction events. The dangers posed by a supernova do not cease immediately after the explosion. The remnants, including shock waves traveling at nearly the speed of light, would continue to pose threats as they spread throughout the solar system. These shock waves could further damage the ozone layer, subjecting Earth to an even greater risk of harmful radiation over time. Moreover, the long-term consequences of a supernova's energy release could linger for centuries, leaving lasting damage to the planet. Conclusion: the importance of supernova research. At present, there are no known supernova candidates near Earth that pose an immediate threat. However, ongoing research is continuously uncovering new potential threats, particularly from supernovae capable of emitting long-range lethal radiation. Despite their destructive nature, supernovae play a vital role in the formation of new stars and planetary systems. The materials they release into space serve as the building blocks for future generations of stars. The heavy elements scattered into the interstellar medium, including iron, gold, silver, and uranium, are crucial for the existence of planets and even life itself. Furthermore, the study of supernovae has revolutionized our ability to measure cosmic distances, offering insights into the expansion of the universe and the mysterious force known as dark energy. Observing distant supernovae has allowed astronomers to map the cosmos with unprecedented accuracy, revealing the accelerating expansion of space.